Awesome. So let's go ahead and look at factoring. Let's go ahead and look at factoring. So when we're factoring, I'm looking down here in this last section. What I've already started to do is look at the factors of 60 in number 68, right? So I look at the factors of 60, negative 30 and negative 2, negative 15 and negative 4, negative 10 and negative 6, and negative 12 and negative 5, negative 20 and negative 3. So let's add all those up. I get negative 32, negative 19, negative 16, negative 17, and then negative 23. Okay, so I think I have what I need, right? I pop in negative 23 right here. And then I have these two factors. So I'm going to have n minus 20, n minus 3. So that'll be my final answer. So again, two steps, break out the factors of that last term. This is only when you have an n term where a equals 1. So that is an implied 1 up front right there. And then we're breaking it into those two binomials, n minus 20, n minus 3. Let's look at 38 as an example. I'm just going to erase this because we did it in the last video. So I'm going to look at number 38 as a kind of quick example here. Let's go in red. So I'm going to multiply these two terms. So I get negative 30. And then from there, I need to figure out the two terms that when I add them together, I get this negative 1 in the middle. So what are the net factors of negative 30? Well, negative 10 and 3, negative 6 and 5 are two that come to mind. So let's add negative 10 plus 3 equals negative 7. Negative 6 plus 5 equals negative 1. Looks like, again, I have my answer, right? So these are my two terms. So I'm going to have x minus, so now I'm going to divide these into the two terms. So 2x squared minus 6x plus 5x minus 15. How did I know to put them in that order? Just because I think that 6 is going to go with the 2 and 5 is going to go with the negative 15 because one's even, one's odd. I can just kind of see that they're going to go together in terms of the numbers, right? Now I just factor those. So 2x times x minus 3 plus 5 times x minus 3. And here we go. I'm pretty much done. I have these two terms right here. So in pink, I've got my common term. And then in red, I've got the term I need to combine. So 2x plus 5 times x minus 3. So I'm going to go ahead and circle that. Again, in purple, always circled. Final answer. Final answer. So same idea down here. What I did with these terms right here is just factor out. I divided them into two separate terms and then factored out their common term. So I put parentheses here and here. And if you have a quadnomial is what I'd call it, or a four-term expression, it's generally going to be parentheses around the first and the second terms. So that's number 39. And then lastly, it's a difference of two squares. So for number 78, I know you all did very, very well in this homework, so I'm not concerned. We can find the square root of both terms, so it's 3r minus 16 to the second power. So right here would be our final answer. Sorry if that got a little convoluted, but those are the expressions. This is a little bit of a trick question in number 45, and this is the last question we'll go over. It says factor the polynomial, right? So what we're expecting is to be able to break this down into its simplest terms. But in this case, we can see that 4 is going to go into all three numbers and a, because they all have an a term and something divisible by 4. And again, 4 is that smallest number. So 4 times a squared minus 5a minus 2, right? And so if we multiply to get negative 2, well, are there any factors of negative 5? I think negative 5 and 1 are really the only factors, right? So there is not any way actually to factor this binomial or this trinomial expression that we're left with any more than it already is. So this is actually going to be our final expression because negative 5 plus 1 equals negative 4. And that is not going to do it for that middle term. So this is the final expression right here would be your final answer. So the idea is to see if it's something that you could factor, and I think you know the rules by now of factoring. So let's just go over the rules of factoring real quick. You FOIL something, right? Again, first, outer, inner, last. And you're going to hear me say that again and again and again and again. And then again, that's just that convention of multiplying the first terms, the outer terms, the inner terms, and then the last term. So remember that tin foil. When you're heating something on the stove, that tin foil is essential, right? I use it every day. It's something you're going to use all the time. Another couple of rules. We obviously have the greatest common factor, and that's the largest term every term has in common. So if I have 10x to the fourth plus 6x to the third minus 9x, well, what's the largest term all of those have in common? Not minus 9x. Let's say it's minus 4x. What's the largest term all three of those things have in common? Well, let's look. Does 4, the smallest number, does that go into 6? Not evenly. Also doesn't go into 10 evenly. Okay, how about 2? Does 2 go into all three of these things? Yes. Okay, so I have a 2 on the outside of the parentheses. And now what else do I notice? I notice that they all have at least one x term. So the 2 is going to have an x next to it. In the middle, we just put what we would multiply by to get back to that original expression. So 5x to the third plus 3x squared, and these are your exponent rules, minus 2. So that would be your final answer. So that's the greatest common factor. And then let's just go over one more thing. What's the degree of a polynomial expression? Let's 6x to the fourth minus 3x to the third plus 10x. Well, what's the degree of that polynomial? That is a fourth degree polynomial. But what's the degree of a monomial? So if I have 6x to the fourth, y to the 10th, x to the, let's see, z to the third, the degree of that is I have to add up all three of these exponents. So this would actually be a 17th degree monomial. So those are kind of three key things to make sure that you go back and review those videos. 1, 2, 3, and 4. I'm going to just go through special cases of factoring. So special cases, 1 is difference of squares. And again, that's going to be a plus b times a minus b. And then we have perfect squares, right? And again, that's just either a plus b squared or a minus b squared. If you have a minus sign, just make sure you look out for that minus sign before this second term right here, just as an example, okay? If you need anything else, just let me know. Send me an email. I'm going to put a couple of example questions up with this set of problems that you should be able to do based on this brief lecture and everything we went over in class today. Again, you guys did an awesome job today. Let me pray for you. Father God, thank you for these students, Lord. Thank you for their diligence. Thank you for their willingness to participate and to commit to their long-term education, Lord, to the things that you have led them into. Father, would you bless them? Would you keep them safe? Would you keep them healthy, Lord? Would you provide for them and for their families? Lord, I pray that they would rest in the shadow of the Almighty, in the confidence and rest, knowing that they are children of God and nothing else. We praise you. We bless you. We ask